Hope you're having a great day. We're going to take a look at solving quadratic equations, quadratic functions. Quadratic here implies that the highest exponent on your x is a 2, x squared. Okay. So, one way to look at a quadratic function is written in standard form, where we have a function a times x squared plus bx plus c, where a, b, and c are real numbers. If we set that function equal to 0, the answers to this equation or this solution are called zeros or solutions. And they can be real numbers, or this is where the previous section comes in. They can be complex. They can have imaginary components to it. Let's talk about square roots a second. If I asked you to find the square root of 25, you'd probably tell me that it was 5. But if I told you to solve x squared equals 25, then you need to include two answers. You need to include 5 and negative 5, because both are solutions here. So anytime we have x squared equals a number, a constant, we can take the square root, but the answer is plus or minus the square root of k. And it's important to remember to throw in the plus or minus. Otherwise, you'll leave out half the solutions. Let's take a quick look at solving an equation. When an equation, okay, so first of all, what kind of equation is this? Hopefully you're thinking quadratic because of the 2 here. You'll notice there's no middle term. In this case, b is 0. There's no middle term. These you can solve using strategies similar to solving for linear functions, like what you did in 7th or 8th grade. Just add 10 to both sides, divide both sides by 2, you get x squared equals 5. The final step here then is to take the square root of both sides, and don't forget that plus or minus part. So in this case, x equals plus or minus the square root of 5. If you check your work, you can plug the plus or minus square root of 5 back in for the x, and you'll find that it works for either solution. So one strategy, I'm going to call this method 1, for solving is just using square roots. Sometimes that doesn't work so well. When we have an x squared and an x term, that doesn't work so well. Here, a lot of students want to FOIL this out or distribute this out. That's fine, and that would get you to a standard form. But there's a little trick we can use here. It's called the principle of zero products. Imagine that this number right here is 0. What is 0 times any other number here? It's 0, right? So let's think about it. How could we make x minus 4 equal to 0? When would that happen? Well, that would just happen when x was 4, right? You can even plug it in. 4 minus 4 gives you 0. Now we could plug 4 in here as well, but it doesn't matter what that is. 0 times this number is going to give me 0. So one solution, one solution to this equation is 4. There is a second solution. That second solution is when this number is 0. If this number is 0, 0 times another number, do you see it's also going to be 0? Well, how do we know when 2x plus 3 is 0? Well, we just can write that down. 2x plus 3 equals 0. We can subtract 3 from both sides, and we can divide by 2. So we now have two solutions here, x equals 4 and x equals negative 3/2. This is the second method that we're going to use to solve quadratic equations. And that's the principle of zero products. A lot of times we'll call it factoring. If you look at part B here, you can see it's not set up like part A, but with a little work we can change it to part A. Do you see how? Give it a try. I bet you can. Subtract 3 from both sides. This is really important. In order for the zero product to work, you've got to have it equal to 0. First step. Then factor. All right. So we've got 2x times x. That's going to give me my 2x squared. I now need to get negative 3. But whatever I put in here to get that negative 3 also has to give me negative x when I multiply. So to get negative 3, I really have just the numbers 1 and 3 or 3 and 1. If I put 1 and 3, do you see this is going to give me 6x? That's not really going to work for my middle number here. So I'm going to try the other way. I'm going to try putting 3 and 1. Now you see that that gives me 2x here, and this gives me 3x. And that's pretty close. I just need to make this negative and this positive, and now everything works out. I've got 2x squared plus 2x minus 3x gives me that negative x, and this gives me my negative 3. So the whole thing here is equal to 0. All right. Now, remember the zero product property, or the principle of zero products? If 2x minus 3 is 0, that gives me one solution. If x plus 1 equals 0, that's going to give me another solution. So then I just solve. I'm going to add 3 and divide by 2. And here I'm just going to subtract 1. So my final answer here is x equals 3 halves and x equals negative 1. Both of those are solutions. All right. Let's look at a graph. We'll call it method 3. Often we're not going to go to the graph, but we can use technology to help us here. If we have a graph and it asks to find the x-intercepts, do you remember what x-intercepts are from chapter 1? Just where it crosses the x-axis, and you can see we have 2 of them. One here at 1 and one at negative 3. So x equals negative 3 and x equals 1. I'm going to write it like this. You could also write it negative 3, 0, and 1, 0. I would accept it either. Now, zeros of the function. Have we defined zeros? We said the answers to this equation can be called zeros. Okay? Well, if you think about it, if I take this equal to 0, where are the y values equal 0? Well, it's at the x-intercepts. It's here and here. So the zeros of the function are the same thing. So remember, we can find solutions on a graph as well as from the equation. And sometimes that's easier. Actually, I just want to show you real quick here. If I had negative x squared minus 2x negative x squared minus 2x plus 3, and I want that to equal 0. This negative out front is a little challenging to work with, so I'm going to factor it out. And now I can factor. This becomes x plus 3, x minus 1. Here, x minus 1, 0, using the zero product property. X equals 1, x equals negative 3. What do you notice? Same thing, right? All right. So I just want you to see the connection between the algebra and the graph. All right, the quadratic formula. I'm sure you've all done this before, but quick review here. If I have a situation where I have it in standard form, then we can find the solutions. We can solve this equation by using x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's just go through an example here. You'll see this first scenario. This is similar to the principle of zero products, where we have to have it equal to 0. Do you see that? We have to have it equal to 0. Well, here it's equal to 7. So to fix that, or to change that, I just have to subtract 7 from each side. We can now try to factor, but what we'll find is factoring doesn't work so well here. And so in this case, we're going to find a, b, and c. A is 3, b is 2, c is negative 7. Notice I need to get it in standard form before I get these numbers. Okay. So I now use this formula. And I just substitute my values in. So x is going to be negative 2 plus or minus the square root of 2 squared minus 4 times a times c. All of that divided by 2 times a. Alright. Now for some simplifying. This is the tricky part. Let's see. 4 times 3 is 12. 12 times 7 is 84. The negatives are going to cancel out. That's going to become 4 plus 84 all over 6. I think I'm going to need all the room I have here. Negative 2 plus or minus the square root of 88 over 6. And I'm okay if you stop here. I know in the textbook they are going to take it a little further, so let's do that as well. And I'm running out of room, so let's try to do this. No, let's not try to do that. All right, the square root of 88. If you remember reducing square roots, if we have a pair that makes a perfect square, and we can then take the square root of that and bring it out front. So 88 is going to become 2. Square root of 2 times 11 is 22. And so coming back over here, I get negative 2 plus or minus 2 times the square root of 11 all over 6. I can then factor a 2 out of it. And then we can divide out the 2, and this is left with 3. So my final answer here in simplified form is negative 1 plus or minus the square root of 11 over 3. Now, I said it, but I'll reiterate. I'm okay with this answer. I'm also okay with this answer. All right. So I didn't say this, but this is the fourth method for solving. There are two answers here. One is to take negative 2 plus the square root of 88. Take that answer divided by 6. The second is to subtract negative 2 minus the square root of 88 divided by 6. Alright, let's take a look at part B. You notice this one is already in standard form. We have it equal to 0. Let's see, what is A, B, and C here? You know what, in fact, I think I might have done some of this already. Oops. Yes, I did. Excellent. So, A is 9, B is 12, C is 4. And you can see how I substituted into the formula. You see we get the square root of 0 here. And there's only one answer this time. There's not two. We had 2 here, 1 here. Alright, let's look at part C. What's the first thing you need to do for part C? Hopefully you're saying subtract 2x from both sides. And you are exactly right. We're going to take x squared plus 5x plus 8 equal to 0. And I've done some of this work already. Let's talk what's A, B, and C. A is 1, B is 5, C is 8. So you see I took the opposite of B, plus or minus the square root of B squared, minus 4 times A times C all over 2 times A. And now, inside the square root, we get negative 7, which is an imaginary number, I square root of 7. And so this is my final answer, is 2 complex numbers. Negative 5 plus that, negative 5 minus that. Alright, so just to point out, we had 3 different types of answers. We had the first scenario. We had 2 real numbers here, one positive, one negative. We had 1 real answer, and we had 2 imaginary answers. So what determines that? Well, if you look, it's the square root. What happens with the square root? Here we had square root of 88 was positive, so it gave me real answers, and it gave me 2 answers. Here we had the square root of 0. It's a real answer, but there's only going to be 1, because when you add 0 or subtract 0, you get the same number. We call this a double solution or a double root. And then part C here, you see that the inside part was square root of negative 7. It's a negative, so it's going to give me a complex answer, an imaginary answer. And there's 2 of those as well. Alright, what happens when we have an equation that's reducible to a quadratic? The key here is to recognize that x to the 4th, x squared, and a constant. We had some of these in the first chapter that we touched briefly. You could also do x to the 6th, x to the 3rd. But in this scenario, we can treat it just like we would a quadratic. Instead of doing x times x, we're going to need to do x squared times x squared. Do you see that when I distribute, that gives me x to the 4th? So now I need to figure out what to put here to get plus 4, and what to put here to get negative 5. Well, to get 4, we've got really 1 times 4 and 2 times 2. If you look, if we put 2 and 2 in there, that's only going to give me 4x squared. But if I put 1 and 4, now when I distribute, this is 4x squared and 1x squared, that's going to give me the 5x squared. Only we need to be negative, so I put minus and minus. Okay. Now, at this point, I would recommend seeing if you can factor again. And you'll notice we can. This becomes x minus 1, x plus 1. Remember, difference of squares. X minus 2, x plus 2. And maybe I should have done that in a different color here. Let's do it like this. All right. We've now completely factored it. We can now use the zero product property, or the principle of zero products. If this number is 0, it doesn't matter what any of these numbers are. The answer will be 0 because this is all multiplication. So we can just go through this. We know that x minus 1 could equal 0. X plus 1 gives me a solution. X minus 2 gives me a solution. And x plus 2 equals 0 gives me a solution. So if I put all of these together, we get x equals 1. X could be negative 1, x could be 2, or x could be negative 2. All of these are solutions to this equation. All right, let's do a quick word problem. If we take a look here, this is talking about free fall. These are called projectile motion problems. And in this case, an object dropped from the top of the Petronas Towers in Kuala Lumpur. How long is it going to take to reach the ground? Well, the key is the distance an object falls can be found by taking 16 times the amount of seconds squared. So in this case, we know to fall to the ground, it's going to take 1,482 feet. We need to figure out how many seconds this is going to take. So you'll notice here we can use the first method. We can just solve and get t by itself. So we're going to start by dividing both sides by 16. Get 1482 divided by 16. That gives me 92.625. And then we can take the square root of both sides. Alright, the square root of 92.625 is 9.62. Now, you'll notice I left the negative off. It doesn't make any sense to have a negative time here. So my final answer here is 9.62 t. Want to highlight that solutions, zeros, x-intercepts, and I'm going to throw the term roots in. Sometimes you might see that. These are all the same thing. It's all taking a quadratic, really any function, and setting it equal to 0. All right, let's take a look at how we could do this with a graphing calculator. The way we're going to do this with a graphing calculator is we're going to set this up as two different equations, and we're going to see where they intersect. With a bit of luck, yes. Okay. Sorry. Oh, and now it's gone. Drat. Alright, well, we'll just type it in here. Y equals 3x squared plus 2x. I believe that was the first one. And y equals 7. See if I got that right. Yep. And now we just look to see where they intersect. In Desmos, it's really easy. You see x equals 1.23. And the second solution then is over here. X equals negative 1.897. Now, if you look at part A up here, you see that's the same thing. Same equation. If you would take either this answer or this answer and type it into your calculator, you would find that it equals the same thing. So I kind of already showed this in method 3, But remember, we can use a graphing calculator as well here. All right, last section. Quadratic versus linear, and I think you're probably comfortable with this by now. Which of these are linear? Which of these are quadratic? Well, we've been working with quadratics, right? So this has an x squared, so this tells me it's quadratic. This does not, so it's linear. This does not, so it's linear. Now this one might throw you. It looks like it's just an x, so you might say it's linear. But if you imagine distributing out this x, you see you're going to get an x squared here. So this one is quadratic. All right. I think I've worked through most of this section. I didn't leave you any practice problems. I'm terribly sorry. All right. Well, that concludes section 2. For some practice problems, you can take a look at the homework. We'll probably also have some that you can do in class. So, quick summary, 4 ways to solve a quadratic. You can use square roots. You can factor and use the principle of zero products. You can graph. And you can use the quadratic formula. Now, I will assess you and ask you to do one of each type. I want you to know all 4 types. Sometimes one is quicker than the others, and I want you to be able to use all 4. So thanks a lot.